most winemakers go to their graves never understanding any of this. And so in this section, I want to boil it all down into something that you can work with and remember. So let's proceed with a simplified overview with some more technical cartoons. So a phenolic is any compound containing a benzene ring which carries an OH on it. A flavonoid is any of a class of 3-ring phenolics extractable from skins and seeds. So it basically looks like that. The A ring and the B ring are always aromatic. That is, they have double bonds flipping around. The C ring has an oxygen in it, and it may or may not be aromatic. Monomer is any discrete small molecule which can serve as a building block for a macromolecule. So here I'm showing the beginnings of a daisy chain from the 8 position on the C ring to the 4 position on the A ring here. Call that a C4, C8, and that's the natural way that flavonoids will polymerize on their own in the absence of oxygen. A polymer is a macromolecule created by linking monomers together. A tannin, this comes from the idea of tanning hides. They used to use walnut shells or redwood extracts, anything that had a lot of tannin in it to tan hides. So what we mean is a polyphenol with an affinity for protein. So once they get long enough, these polymers can interact through what's called hydrogen bonding. These are weak interactions. They're not covalent bonds, but when there are enough of them, we get cooperative binding, and the two of them will stick together pretty tightly in a sort of a zipper effect that we call cooperative binding. Now let's talk about the importance of color. Of course, you like wines to be darkly colored, and so there's an importance there. It's also a key indicator of ripeness because it's the only thing that grows up and then declines. This is monomeric anthocyanins. Once they start to polymerize, they can decrease their numbers during ripening after a certain point. And so the peak of monomeric anthocyanin is an important signpost when we're looking at grape ripening. They're also vital to polymerization chemistry and therefore critical to wine texture. Anthocyanin is any of 5 red-colored flavonoid monomers, and they are critical to red wine texture and longevity. And the reason is that they can't polymerize, so they form the terminal on polymerization and make the tannin chains shorter. When they're 5 units or less, we call them oligomers, and this is an example. Now, unlike monomeric anthocyanins, polymeric pigment is stable, doesn't ionize, doesn't have a colorless form, and it's unbleachable color and is the basis of fine texture. So when we have a lot of anthocyanins, we tend to stabilize our color and end up with soft texture that's very stable, and so the wines have longevity and they don't tend towards dryness. If, on the other hand, we have poor color, then it won't stabilize very well. We will lose softness and promote dryness as the polymer gets longer and longer without termination, and we have tighter and tighter binding to salivary protein and eventual precipitation as the complex gets too heavy to stay in suspension. Coming up next, the postmodern view of tannin terminology.